All right, welcome scientists, students. We are going to look at the second part of our calorimetry lab. And in this one, what we're going to do is we're going to have a metal and we're going to change the mass. So here we have 20 grams of that metal, 100, 150, 200, 250, and 500. So it's the mass that is going to change in this experiment. Like we did before, the temperature of that metal is going to be starting at 100 because we put it in boiling water. The mass of water, we're going to start with 50 grams of water every single time, and the water starting at a temperature of 22 for every single one of the cases. Okay? We take the very hot 100-degree metal and we put it into the 50 grams of water in our styrofoam cup calorimeter, if you remember how we did that before. And we measure how much the temperature went up. What's the final temperature that it goes up to? So when you put the 20-gram piece of metal that has an initial temperature of 100 degrees Celsius into the 50 grams of water, and the water started at 22, now the temperature is 24. The water's temperature went up to 24. So I want you right here to calculate the change in that temperature. Obviously, it's going to be 24 minus 22, and type that number in there. So 24 minus 22, you're going to have a change in temperature of 2. Okay? I want you to do that then for all of these different masses of metal. When you put in 100 grams into the 50 grams of water, now the temperature went up to 29. When you put in 150, temperature went up to 32. 200, 37, 250, 41, 500, 55. Take a second and calculate the change in temperature for each of these different masses of metal that you put into the water. You can pause the video and calculate the change in temperature. Okay, if you came back, you should have gotten these values for your change in temperature. So 2, 7, 10, 15, 19, 33. You can see that the change in temperature is increasing the larger the mass is, okay, which makes sense. If you use a larger piece of metal, that's going to be carrying more heat into the water. It's going to raise the temperature of that water more, okay? Now, the next thing I want you to do is to actually calculate how much heat is absorbed by the water from the metal. The formula that we're going to use is right here. To find the heat, you take the mass times the heat capacity, and the heat capacity is a specific number for whatever substance you're using. In this case, we're going to be talking about the water, times the change in temperature. So for water, what you would do to find the heat that the water absorbed, you can take the mass of that water, which is always 50. It's always 50. Times 4.18, that is the specific heat capacity for water. That number never changes for water. And then times the change in temperature. Well, the change in temperature you just calculated right here. So I want you to use this formula right here and find the heat absorbed in each of the different cases using that formula. You can pause the video and do your calculation. It's just mass, which is 50, times 4.18, times this number in the column here of change in temperature. So for row 1, it would just be 50 times the heat capacity is always 4.18 for water, times the change in temperature, which is just 2 for row 1. And you've got your heat. Do that for every line, every row, and fill it in. And then come back. Pause the video here and then come back and check. Okay, you should have gotten these values here. And you can see that the heat, the amount of heat that is absorbed increases because you're putting an increasing mass of metal into the water. So you can see that mass is definitely a part of this formula. So the larger the mass, the more heat that mass is going to contain. And in this case, the metal transferred a lot of its heat to the water, and the temperature of the water went up. Okay? Now, we are going to graph this, and we're going to graph a couple things. We're going to graph here. I want you to click and then drag down to highlight this column that says mass of metal. Then we're also going to graph the amount of heat over here. That's going to be on the y-axis. So to do this column here, I believe you have to click on Control, click the button Control, and click your trackpad and drag down. So you have these two columns are now highlighted separately. Okay? Then you're going to come up to Insert. It's just above the viewing window here. So go to the Insert tab. It's just right above the viewing window here. You can't see it on the screen. Go to Insert and then choose Chart. And it automatically will select the type of chart that you need. And you can see now from our chart that when the mass of metal here, plotted on the x-axis, increases, the amount of heat is going to be increasing as well. Okay? More mass, more heat is being able to be held by that particular metal. Okay? And there is a direct relationship. It's going up as the mass increases. Okay? So we're just going to drag this down here below. And that is looking at today's lab. Again, what you need to know is that mass, the greater the mass, the more heat it is able to absorb and even transfer to another substance, that other substance in this case being the water. In the part 1 of our lab, we did the heat capacity. We looked at different substances. Okay? So the heat capacity in the previous part 1 lab was the different substances. And we looked at iron and copper and aluminum, and the heat capacity also had an impact on how much heat. Okay? So part 1, the previous lab, we looked at heat capacity, and now today we looked at mass. Now, what we'd like to do is we're going to do some more calculations with this formula. Okay? As we look at this formula, we're going to look at how we are going to use this formula to calculate either heat, we could find the mass, or we could actually find the specific heat capacity. So it's the same formula in all cases, it just depends on what we want to find. If you want to find the heat, then to find the heat Q, that's going to be the letter Q, you have to take M, which is mass, times C, which is the heat capacity, times the change in temperature. Okay? To find the mass, you would take the heat, Q, divided by the heat capacity, and then that number divided by the change in temperature. Same formula, but it's solved for mass. To find the heat capacity, that's the letter C, you take the heat, divide by the mass, and then divide by the change in temperature. So we're going to look at a series of problems here, and all you have to do is follow along with me, and on a separate sheet of paper, you are going to solve these problems and then turn that paper in. Okay? So let's look at number 1 here. Okay? It says 50 grams of copper, so that is the mass. Okay? You're given the mass. Was heated from 20 to 80. There is going to be your change in temperature. Okay? So you can see that it went from 20 to 80. That's a change of 60. That's going to be your delta T. How much energy is used to heat the copper? And then they give us the specific heat capacity of copper right there. That is the C value up here in the formula. So all you have to do to find the heat, how much energy. We're using this formula right here. You're going to take, on your calculator, mass times the heat capacity times the change in temperature, which is 60. Do that calculation, show your work, and put it down on a piece of paper. You can pause and finish the work and then come back for number 2. Okay, for number 2, again it says how much heat. So we're going to be using this first formula. They give us the mass, that's your M right there, and the temperature is going from 10 to 29. That's a change of 19. That is your delta T in this formula. 10 to 19, or 10 to 29, that's a change of 19. And the heat capacity of granite is 0.1. So you're going to use this first formula. You're going to take 20 times the heat capacity times the change in the temperature, which is 19. Do that calculation, pause the video, show your work, and then come back. Okay, number 3. Again, it says how much heat. How much heat? So we are given the mass of water, and it's at 96, and it's going to cool down. So this time heat's going to be taken out. Heat's going to be released. But still, we can find out the change in temperature. All you have to do is you take 96 minus 25. That's your change in temperature. That's your delta T. So we're going to take mass times the change in temperature times the specific heat. Okay, in this case, the specific heat of water is 1 because they're using different units. They're using calories instead of joules. 30 times the change in temperature times 1. Okay? Do that calculation and then come back for the next one. Okay, in this one, you'll notice the question is find the specific heat. So that means we are going to be using this formula. To find the specific heat, you're going to take the heat, the total amount of heat absorbed or released, divide by the mass, and then divide by the change in temperature. So I'll talk you through this one. This time it says right here, you have a 3.1 gram ring, that's your mass. It is heated using 10 calories. That is heat. Calories is another unit for heat and energy, like joules. That is your heat. And its temperature rises 17.9 degrees. So if I look at the formula up here, I'm going to take the heat, which is my 10, divide by the mass, 3.1, and then take that number and divide by 17.9, and you'll get the specific heat capacity. So do that calculation, show your work, and come back for number 5. Okay, in this one it says what is the mass of the sample? So we're going to use this formula. What do? You're going to take the heat divided by the specific heat capacity and then divided by the change in temperature. So it says in number 5, here it goes from 20 to 46, so you have to subtract those to find the change in temperature. And it absorbs this many calories, so that's the heat. And here's the specific heat capacity of water in calories per gram per degree Celsius. It's 1. So you're going to take your heat, that number, 5650, divided by the heat capacity, 1, and then divided by the change in temperature, 46.6 minus 20, whatever that difference is, and get your answer. Okay? Let's go to number 6. Here it's asking, what is the specific heat of iron? What is the specific heat of iron? Again, we're trying to find the specific heat. That's this one. So you're going to take the heat divided by the mass, and then divided by the change in temperature. Heat divided by mass divided by change in temperature. So let's find the heat. There it is, 47 calories. Take 47 divided by the mass divided by the change in temperature. To find the change, you have to subtract the final and the initial temperatures. So subtract these two temperatures to get your change in temperature. 47 divided by 10 divided by that change. Okay? Do that, write it down on the piece of paper, and then come back to number 7. All right, in number 7, this says, what was the final temperature of the copper? Okay, now this one's going to be a little tricky, but we can do this. I'll talk you through it. This one is asking us to find the temperature. So what we're going to do first here is we're going to find the change in temperature. All right, so I'm going to change this just a little bit. Find delta T. Well, if you take this formula and you want to find delta T, then I have to take the heat, divide by the mass, and then divide by the heat capacity. We're going to find the change in temperature. Okay? That's how we're going to do that. And then once we know the change, if we know the initial or the final, we can find the other one. So this is the one we're going to do here. In number 7, we want to find the temperature. It says find the final temperature. Well, we have to find the change in temperature first. So here's what we got to do. We got to take the heat divided by the mass divided by the heat capacity. Okay? I'll give you all these formulas when you need them. So let's come down here. I got to take the heat. Here it is, 54 calories divided by the mass divided by the heat capacity, and that's going to give you delta T. Okay, that's the change in temperature. It says, what was the final temperature if the initial temperature was 25? So if it started at 25 and you just found the change in temperature, then you have to add that change to the initial. Okay, heat's being absorbed. Take your change and add it to 25 to get your final. Okay? You can pause and finish the calculations and then come back for number 8. Okay? All right, in number 8, notice it says, what is the specific heat of the substance? So we are trying to find the heat capacity. We're going to take the heat divided by the mass divided by the change in temperature. Heat, mass, change in temperature, dividing. So we're going to take the heat here, 569 calories, take that number, divided by the mass, and then divide by the change in temperature. You have to find the difference between 25 and 40 and divide by that. 569 divided by 155 divided by the change, the difference between 40 and 25. Okay, do that calculation, show the work, and then come back for number 9. Okay? All right, last one. It says, what is the specific heat? So we're going to find specific heat. We're going to take the heat divided by the mass divided by the change in temperature. Okay? So we're going to take the heat, 12 calories, heat divided by the mass divided by the change in temperature. This temperature is going down, so we're actually trying to find out how much heat is released, leaves the metal. So 25 minus 20 is going to be a change of 5. You could put -5 if you want to, and the negative would indicate that heat is leaving. But it's going to be 12 divided by 2.5 divided by 5 degrees Celsius. and that's going to give you how much heat leaves the sample. Show your work. Okay. All right. That should all be on a separate piece of paper, and you're going to turn that piece of paper into me so I can check it. So you should have two things done today. We did our lab, realizing that increasing mass increases the amount of heat. Okay, we looked at that right there. All right, so the increasing mass of metal increased the change in the temperature of the water, and that means that more heat was transferred from the bigger pieces of metal to the water. Notice the mass of the water never changed. We were changing the mass of the metal. Okay, and here's our graph to show that. You can see there's a direct relationship between mass and the amount of heat, and that shows in our formula. So in our formula, when you want to find heat, then it is mass times the heat capacity times delta T, which is change in temperature. This mass, as the mass increases, heat increases. This C, as this C value is bigger, depending on the substance, that changes depending on the substance, then the amount of heat that it can hold and absorb and transfer is bigger. And delta T, obviously, if you want to increase the temperature of something dramatically, then you've got to, apply a lot of heat. So you can see how those three things, mass, specific heat capacity, and delta T, all affect the heat. Okay? All right, let me know if you have any questions, and make sure you get these two parts done today and turn in the one that has the practice problems.